Maxime. We call us also the M&Ms. So, GSK, so little exercise. We know you're maybe not awake anymore, etc. So, who knows GSK? Please stand up.
Yeah, stand up. All right, and I have another question, is who doesn't know GSK? Please stand up also, so that everyone wakes up.
And stay up. So basically, in the room here, within GSK Vaccines, we are producing around 2 million vaccines doses every day in Belgium and around the world as well, in Italy. So you need to know, you can sit down. So what we have currently in our pipe is 43 vaccines in our portfolio, and we have 21 vaccines that are under development. So that's a bit of the story about GSK. We haven't participated to the COVID race. Sorry for that. But yeah. So, there. Who are you, Maxime?
Okay. I am introducing myself very quickly. My name is Maxime Brochier, and I work in digital innovation and beyond departments where we focus on disruptive innovation. And I've been on the process mining journey for a few years now, while I was actually studying a postgraduate at KUL University in Leuven in Belgium. And this is where I got introduced to process mining.
Thank you. And I'm Maxime as well. I'm a business innovation lead in clinical laboratory science. I studied as well at the same university as Maxime, a postgraduate in big data analytics, and that's where we have known about DISCO. And so that's where the journey starts. So I'm going to talk to you about an acronym. I'm pretty sure no one knows what HBSM means. HBSM, it's Human Biological Sample Management. So it's really focusing on clinical studies here. So what is the process? Of course, when a study starts, you design what you want to test, what virus you want to perform the tests on, etc., to ensure that the vaccine is safe for the patient, because you want to save patients' life at the end. So patient recruitment afterwards, of course, who wants to participate, who needs to bring or go to a hospital, to a doctor to give samples. We vaccinate the patients, of course, with placebo or with, I would say, development vaccine or real vaccine. And then that's where we start, and that's where the journey about process mining will start and what will be explained. We collect samples. So you go to the hospital, the site investigator gets samples, blood samples, swab samples, you know, all the COVID swabs, really annoying in the nose, etc. But so those are really a lot of different types of samples that we can collect to really, during the clinical study, ensure that the testing that we perform proves that the vaccine is working well, is performant, safe, efficient, etc., etc. So as from the sample collection, what is happening, we gather the samples and we bring them to GSK Vaccines or to external partners called clinical readouts partners. As from the moment the sample has been gathered, they are coming with a truck at GSK, so in Rixensart in Belgium, which is the center where the clinical laboratory science department sits. So we have around 45 labs where people are performing 4 different types of test platforms. So you know the PCR, but we also have immunology assays, we have functional assays, so we test different parameters to ensure that the vaccine is safe, performant, etc. As soon as the sample at GSK are arriving, we store them in fridges, minus 80, minus 120, 195, etc., etc. Then there is a step of preparation. Preparation means we have the mother tube, we got a serum sample or a plasma sample from blood. We split it in smaller tubes to ensure that we can test all the different test platforms. Then, of course, a lot of sample logistics about, okay, what lab needs to test this platform, a test platform or the other one. So around the 35 different labs, testing labs, we need to give the samples over to the scientists. Then there is the testing of those samples. So they put it in wells, they dilute it, and then all the testing activity is happening and generating then, of course, test results. This is definitely where we are interested at GSK, is knowing what is the result of a specific sample based on a vaccine that we want to commercialize, to bring in phase 1, phase 2, phase 3, and of course to, at the end, vaccinate people with them to ensure that they are not contaminated by the virus, or at least that they can be saved or be cured as soon as possible. After those results, they have been analyzed with statistical things, models. I'm not a stat man, so I cannot explain everything what happens there. And we then publish publicly the results of the study. A lot of steps, really important in pharma. We need to track and trace everything. So every single step from sample collection till the result generation, scanning the tube, preparing the tube, scanning the tube, preparing the tube, scanning the tube, putting in that lab, scanning again, a lot of different steps. The important point for GSK is bringing vaccines faster to market. So if we can decrease the lead time overall on all those steps, we are winning, you are winning, everyone is winning. So how we could use process mining to speed up the process, capture a lot of data, make a diagnostic analysis of all those data through process maps, to DISCO, and really to ensure that for the 60 million samples that we currently store at GSK, we know where they went through, what is the happy path, where we can identify bottlenecks, best practices, and apply them overall on the process. And there you go. Okay.
Thank you very much. All right. I will walk you through the little techie part of the presentation, which is the data transformation journey. And I just wanted to emphasize on the fact that we have a very large amount of data that we need to handle, because we're talking about millions of samples. We're talking about hundreds of activities, a cycle time that taken years, 5 years to develop the study and to collect the results. So it's a big piece of information that we need to manage. And I think that's why we are presenting it to you, because you might not care about what we actually do at GSK, but maybe you can apply it to your type of data set if you have a very large amount of data to handle. So first part of the problem was to extract the data. So we have our SAP ERP, and we have so many tables actually that gather the data. And we started with a manual extraction, as anyone. And the manual extraction was taking about 6 hours a day, more or less. So you need someone every 30 minutes to change table, request the extraction, wait for half an hour, etc. So someone is not idle doing nothing in the meantime, but still it takes a lot of time to do it. So the first part we do was to automate it. So we developed an RPA bot, robotic process automation bot, that could just extract the data to make sure that no one is doing this, actually, I think, not very interesting task. And actually, also, the data stays always the same. Because you might start an extraction and say, oh, but I forgot to add this column that normally I had. And so you need to retransform the data, recollect it. So we have automated this part. Afterwards, we needed to transform the data. Usually, when you have a small amount of data, you can open an Excel sheet, transform, change, clean, do whatever you want, pivot tables. In this case, because we are talking about millions of samples and so many activities, we cannot actually open those. Even the extract from SAP, we cannot open it on a normal computer, because otherwise it will time out. So what we use is Azure infrastructure, Microsoft Azure, because it's our partner at GSK, to actually load the data and develop a transformation engine. So we develop in Databricks using Python and SQL code, all the knowledge and all the intelligence of how we clean the data, how we treat the data, and make them look actually digestible for such a tool as DISCO. Why do we do that? Because we cannot do it manually on an Excel sheet, but also we can reuse it as many times as we want. Second thing, well, third thing we did is actually automate it so that there is one RPA bot extracting the data and another one pushing the data into the transformation engine in Azure, and then having actually clean file that can be read by DISCO. The end of this process is that generated file that you cannot actually even open, because there are too many lines. So whenever you open it, it will time out. But we actually don't care, because we are not reading it. DISCO is reading it, and it's doing it very quickly.
Yeah, maybe one thing, our case ID unique identifier is the barcode that you have on the samples. So it's a serial number, unique for each tube. A patient can give four tubes, but he will have 4, I would say, unique identifiers.
Good precision. So you have an idea of what we do in the journey that this tube or this sample goes to. So what's next? Analyzing the data with such a Disco tool. And so here you see actually the full journey. So as we said, we automated the data extraction, the transformation engine within Azure. Then we load it directly into Disco, and we start analyzing the data.
This is a clean process map. We had like a, it's not anymore called spaghetti, basically.
Yeah. It was even more than. So I'm here also to give you some tricks that you can apply to your own process mining activities, because again, you need actually to develop it for your companies. My first tip would be audit trails table are gold mines, and sometimes we don't think about it, but in a lot of ERP system, every time something has been changed, updated, or whatever, you have one line encoded somewhere in an audit trail table. And actually, those tables are gold mines. And even though it doesn't look very interpretative, you can interpret those data and say that whenever this value has changed from active to not active, it means that the testing activity has started, or that the sample is physically available in the lab testing, because you actually scan the barcode that it's arrived at the right lab. So gold mines in audit tables, please take that into account. Another tip that I want to share with you is how do you deal with a lot of activities. As we said, we had hundreds of activities, and we wanted to reduce this amount because otherwise it's unreadable. Even with a clean version of our data, there is so many steps that it's a bit difficult to see. What we did, for some of them, we are only start timestamp. So for example, we send the samples for testing activity, and then we receive the sample from testing activity. Those are actually two different activities with a start time and another start time. What you can do is bring them together if you know that there is no activities in between, and use the start time of the first one as the start time, and the start time of the second one as the end time, as shown in the screen. And it's a very basic transformation that actually gives you a process map that is a little bit more understandable. It shrinks the process map. Here you see it in a very simple example. You actually don't miss any single information, because actually the information of the 32.2 hours are actually fitting in the activity, the first activity you see on your right. But you can also do that with many more activities. If you know that there is no other activities there, you can miss some information and go from task mining, which is with a lot of granularity, into process mining, and do the same. You regroup all those activities. For example, you receive the sample, so you receive the tube, you put it in a store, in a fridge, you leave from a fridge to another one, you check temperature, you put it in another fridge, etc., etc. Those are all information that you might not want to see. You can group those activities by taking the first one and the last one, and group that into a single activity that you can call warehouse activities. So it's the same principle as before, but the result is that you get a very easier, understandable process map. So that's tip number 3.
And indeed, we have I think more than 10,000 different freezers. So if each time a sample goes from fridge A to fridge B, then fridge C, etc., at the end, the process map is a soup. It's not a spaghetti, it's a soup, because you don't care about what fridge, you just care about the activity that happens.
Mm-hmm. So that's something we also did in the transformation engine, is say, okay, let's not look at the name of the fridge, let's group it into moving into a fridge, no matter which fridge it is, because actually you don't really matter, you're not trying to locate where it goes, but actually just understand what are the movements within the warehouse or the storage or whatever. Tip number 4, we had a very specific case here in HBSM that your sample might be subdivided into various samples and actually make various results. But the thing is, you might have a mother and then children tubes. And so what we did in order to keep a trace of everything and still having something that we can process mentally, because you want to, compare apples with apples, is that we are replicating the activities of the mother into the child history, and we get rid of the mother. So I will try to skip the animation, just so you see each child have different kind of activities. And then what you are trying to do is to replicate these activities into the children. So that afterwards, you have, let's say, a clean version. You see the full children path from its mother to its last steps. That's something you can also do so that you can afterward get rid of, let's say, the mother information, and you have a more understandable data. Last but not least, my last tip, and then I'll give the floor back to yours, Maxime, is that you should start small and scale fast. What we say by starting small, we started with manual extraction, having a fully manual transfer of the data, cleaning of the data, and interpretation. Then we had some semi-automatic process where we had RPAs extracting and then loading and then transforming the data, until you can even have an ETL tool, extract, transform, load tool, that can do the full process for you, so that you keep a trace, you keep data up to date. Actually, for this specific experiment, we were focusing on some very important and key strategic vaccines for GSK. So we needed to have daily update of the data, because it was very important to keep track daily on the updates of the result for the studies. So this is why we had to automate the data transfer, because you can actually extract those data every month. It's okay to take 6 hours to extract it, but when you have to have daily feedback update, you need to automate the process.
And to bring, to enhance what Maxime said, we are multiple pharma companies working potentially on the same vaccines candidates. A good example is with COVID, Pfizer won the race. We didn't really participate. But if you're first on the market, of course, the company is more wealthy, is more and can do more, is making more money, basically. So indeed, we are always in a race. As soon as you can really monitor your process more precisely on a near real-time basis, with process mining evolving to process monitoring, definitely you can gain value, you can identify bottlenecks, but you can directly see if there is an outlier, why is that sample not coming back as planned? And you can just then dig, make the process change over there, and say, okay, directly track and trace in near real time.
All right, thank you. I'll let you give the results.
So results before and after, we had the process mining in place on that specific priority study. When you have a sample collected at a hospital, you have the doctor who is using a specific platform, not owned by GSK. We cannot access the data from the patients. We cannot know, okay, it's a sample from Maxime. We know it's a sample of subject 1 for that specific study, for that specific visit he went to. So otherwise, you can base the results of the clinical study. And so a lot of data reconciliation steps need to be done to ensure that the test we've been generating is indeed for subject 1. And so from a stats perspective, etc. So what was in place before? We received the sample at GSK, so physically we scan it. So it's in our SAP system, Extended Warehouse Management. And we cannot start the test. That was the process. We cannot start the test until we know that indeed that sample has been collected. Because it was an outside system at the site, at the hospital, basically sometimes we were waiting for 3 weeks. We already received the sample at GSK, but it was not registered in data management that indeed the sample has been collected. So we couldn't start the testing phase and not, I would say, generating the result. And we are in a race, so we need to go fast. After, I would say, the process mining approach, and after having identifying that insight about, okay, this is something we can change in the process, why do we wait for 2 weeks till indeed the other system telling us to data management that we have been collecting the samples 2 weeks ago before we received the samples? We decided to directly test while the data were reconciliating. So this is basically has bring, I would say, our 2 weeks going faster. So reconciliation was done in parallel of the testing of the sample. The result was blocked, I would say, before at the time the reconciliation is done, till the reconciliation is done, the result generation was blocked. So there was no transfer to data management about the result of the samples. So prepare the sample faster. Preparing is taking the big tube, taking a pipette, put it in some smaller tubes, or for example, some swabs, remove the swab from the big tube, taking, I would say, the liquid in it and the virus, and pipetting it. We were finding through process mining that the system, we needed to click too much time to ensure that full traceability about the preparation was done inside SAP. So we decided to remove some steps from clicking for the users, and instead of having 4 clicks, 5 clicks, 10 clicks, we just improve the system and change the process and change the system as well by putting a 1 click. So that is how it looks before and after in Disco. You see indeed that your process steps are decreasing, you're going faster, the user is happy because sometimes his finger is hurting. So that's another result. This one is very important. It's sometimes difficult to access data inside the organization. It's even more difficult to get data outside the organization that are part of your process. So when you have a lack of visibility of what is happening outside, and typically that's the case at GSK, you know we are working with hospitals to collect the samples, we are working with external partners to gather the samples, and then we get them at GSK. So our system starts tracking the samples as soon as we get them. So we were able to improve the process internally at GSK, but no visibility on what was happening outside GSK. I'm just giving an example that we have been able to identify at external partner process. A sample in Brussels, it's not in Brussels, in Ghent. A patient went to the hospital giving a sample, and our gathering company is in the UK. Our testing lab is in Belgium. So the sample went back to the UK to then come back to GSK in Belgium. So we lose about 15 days just to send a sample to the, I would say, external partner to gather them together and to then bring them at GSK.
And actually, while Ghent and Wavre, where the site sits, it's about 30-minute drive.
Yeah. So, stupid. So, what we did is indeed pointing towards discussing with the external partners, of course. We have a contract in place with them, so we can ask for data. We are accessing new data sources that can give us better information on when the sample, for example, is collected, when they have been arrived at their site, where they have been, I would say, put in some boxes, labeled, etc., reconciled, and when they are being sent back to GSK. So we can see how many steps there are there based on their database. And it also enables us to better plan. We know when a sample is collected, really. We know when it's at the external partner, so we can better plan our throughput, our availability at lab testing, preparation step, reception step, from a resource perspective, but also from space perspective, if we need more labs available for that kind of test platform. So indeed, there you add some steps in your process. Normally, in process mining, you want to reduce your steps. In this case, if you increase your visibility, if you increase your data that you're bringing in, you can have really better insights as well. So how to act on the process? So it's more about change management. We had very good discussions with the change management working group. What we did from a change management perspective, indeed, we need to directly discuss with the business subject matter experts about what is the process currently that you have. You have a video flow with a lot of boxes. That's what you think you have. And then we are bringing data from SAP. We're using process mining insights, and we share them with those business. So we really involve the end user, the business process, I would say end user, about what we have been found. For that specific critical study, we have been deployed a Flex team. I don't know where that name comes from, but yeah. So for that study specific, for each critical study or priority study, we have been deploying a Flex team with the study expert, the study manager, the process experts as well. And we were basically discussing with different types of profile experts there on what we've been able to find inside Disco, And after we are moving towards little by little to Celonis, but it's less, I would say, easy to implement. What we've been able to find and sharing with the team, sharing with the study team on how we could act on the process itself. That is kind of a what, who, when, an agenda of daily or bi-weekly meetings we had with the study operation team, with the flex team. We address the inefficiencies. We can see what is the impact if we change the process and who is going to, I would say, follow the actions that we need to put in place to change the process itself. Then second team is the lean operation team, where basically it's all, I would say, the studies that are prioritized. We are discussing what has been decided in the flex teams to put them together to see if some inefficiencies are indeed not only for one study but for multiple studies. And then we take some decision, bring some proposal to, so that's again the what, who, and when. You'll get the slide deck, so don't hesitate. And then we have the Octopus team. Octopus team is kind of our leadership team. If a change is of high risk, of high impact on the process itself, then of course we need a person who is deciding that indeed we can take that risk. It's a smart risk. So as soon as we have the decision made, and you know the process at GSK, it's kind of like at government sometimes, it's really heavy, it's a big boat, it's not a smart, I would say a fast boat. Then the change management, the change impact assessment is done, and we have a team who is deploying it, really changing the process together with the flex teams, of course. Really important in process mining and monitoring, always show KPIs. KPIs of what has been, what are the insights, what are the inefficiencies, the bottlenecks, what is coming out of the change that we've been implementing. So that's the whole flow.
And if I may summarize, I think it's very interesting to see that you have both business SMEs, very important because you cannot analyze really the process without the SMEs, and the Octopus leadership team who can take action while the SMEs say, okay, we have a problem there, this is how we're going to improve it. You have embedded in the team, the leadership team that can take actions and say, okay, let's change that, let's change the vendor, let's parallelize those activities to get things faster.
And of course, I haven't mentioned IT, of course. We are talking about business, but
I'm part of IT, that's
IT is definitely involved. So as a summary for process mining at GSK is don't start with a fancy technology because you want to have a new technology implemented. Really start with the problem. Our problem, we want to accelerate a study. We want to accelerate the clinical result generations. Get the right experts around the table. IT, in the room, data analysts from GSK are there as well, cloud experts. Business experts, of course. If you don't have the business, don't make process mining. Explore a lot. Explore how the process is currently done, how they think it's currently done. Explore the data that you can gather. Explore the different technologies that you are available. Is it, I would say, Azure you're going to transform your data? Is just Excel or whatever? The amount of data that you have available. Can you bring other data from other systems? Structure the data. Change the data, transform the data, a big part. Always iterate. If you can bring more data, and if you say it's not enough data, just like be agile. And if you don't capture the right problem in the beginning, just refine the problem. Bring additional experts, remove experts that you don't need. So really, you can start over and over. After that, I would say after the data is structured, validated, your activities are clearly defined on specific case ID, validate them. Because if the business doesn't say, this is completely crazy stuff, it's not possible that you can go further with the process mining. Get the insights, and then you go back, I would say, to the Octopus team to apply the change, to implement the change, and observe if the change is indeed efficient. And that's it.
maybe
we still have 30 seconds.
We have 30 seconds.
I don't know what I'm going to tell, but
if I may,
yeah.
Thank you very much, Anne, for bringing us here, because I think we were all very interested by today. I know it's a big work to organize that, so thank you very much for the invitation.
Oh, thank you. Well, we do have time for just a few questions, so let's do that. So if you have questions for Maxime, and Maxime, raise your hand. I just have a very quick one from the beginning when you were talking about the data transformation stuff. You mentioned the different fridges, right? Fridge 1, Fridge 2, Fridge 3, that you are not looking at those. I was wondering, is this also something that you had to do in the data transformation? Did you had to parse out generic parts of more detailed kind of strings or something like that, or?
Can you repeat?
You want me to go ahead with the question? So,
yeah, maybe I'll repeat the question.
No, so we had to put into our transformation engine that we need to simplify the data. At first, we had so many different activities. We actually understood that because we were taking into account the name of the fridge, for example, or those kind of things that actually don't really matter. We just want to understand if we move it from a fridge to somewhere else and then back into a fridge, no matter the fridge, then in our data transformation engine, we have simplified the data to reduce the amount of activities that we had. Yeah, that's something.
Yeah, and maybe to bounce back on that one, as on Agile, we started to extract a small part of data, getting, okay, what can we get out of it, concatenate fields, cleaning the data, etc., and then bring other data inside. And so, indeed, it's an iteration. The transformation engine was not built in one day. Of course, it took, I think, 2 or 3 months to define the different rules of transformation, to say this is that activity based on, I would say, the audit log tables. So indeed, yeah. Data cleaning, data transformation is something that is evolving.
Yeah. Okay, great. Okay, who has another question for Maxime? Over here. Is this a question? No. No. No questions? Well, one question over there. Let's get the microphone.
Eminem. Never forget that. You talk about a lot of ETL, extraction, transformation, load. I was wondering, your source system, if I saw the screens and you mentioned I saw some SAP screens coming over, yeah, right? The ETL, in which environment are you doing this?
It was Talent, so it was cloud-based.
Yeah, so the name of the ETL is Talent, and actually this is our
that
enterprise.
was on the sheet, right?
Yeah. This is our enterprise choice because our data. We decided that we would use Talent to migrate our data from SAP to Azure and to Azure to any other environment, and so we use this one as a company choice.
It was not our choice. It's something.
It's more architecture decision to make sure that we can easily handle the data without impacting, for example, SAP's transactions. And we can see.
Okay. The other thing is the first results that you showed in this presentation. You realized it by applying the Disco tool, I assume. Is that correct?
Yeah. The thing we have shown actually before, maybe Maxime will show it there. So the decision we took about here, for example, parallelizing data. That things that has been shown, indeed through
to the process mining steps, yes, indeed,
using Disco.
Yeah. The reason I ask is because you mentioned also in your presentation that for GSK now the transformation to Celonis as a tool is going to be, right?
So I think there are different tools for different purposes.
Okay.
And that's really, I think, what you would do in Disco, you can do it in few hours. You might be able to do something with Celonis, the same result. You might take months to be able to do that. But you can do other things also with Celonis, like you cannot do with Disco. So I really think that those are very distinct tools that we will keep actually using in parallel for different purposes.
Yes.
Definitely to bounce back on that. Disco is more, I would say, quick to be used. Yeah. Celonis takes months and even more in pharma because you need to validate all the RT systems. So sometimes you want to cry. And definitely, I think the advantage of Disco towards Celonis is that you can bring data, you can extract other data, you can bring them again. If you need to have a connection towards Celonis, you need to ensure that all the transformation engine is already in place.
And the pipeline, the data pipeline through the different databases are correct. They don't stop. You have no change in the tables. You have no change updates on the server or whatever. So there is that maintenance part because you automate everything in order to monitor it.
Yeah, what you explained to me is I'm exactly in the middle of this. I like to do the exploration work and not building a production pipeline. Otherwise, I will be in another IT department. Thank you.
Exactly. And if I can just add one little thing, I really think that 90% of the cases, you just need to do one-shot analysis that you can redo every month, for example, to see how it improves. You don't have to have day-to-day update of the data, for example. And it's a very huge amount of work in order to do that.
And just to enhance on that one, I was asked to extract the data with Maxime and with other colleagues, 6 hours 30 per day, because that study was really critical. So there, indeed, it was a priority. We needed to do that. It was not a fun at all. So that's why the automation part comes into the picture also. When you need to monitor, it's monitoring. It's maybe, I would say, not process mining again, but it's really monitoring to know in what time a sample is coming or when it's coming. I think the big gain of Disco is really quickly show where is your process bottlenecks, where you can, I would say, increase the efficiency. Celonis is more about monitoring, I think.
Thank you for this explanation. It will help me also in sample selection.
Great. I have a question there.
Hi, thank you for your presentation. I have one specific question about your data transformation. You applied the example with the mother and child, this different object view. Did you find yourself any bias in the analysis? Because when you're transforming like that, you can have 3 times the same activity and 3 times the time for performance analysis. And did you find it? Did it affect? And how did you tackle this case?
I think I have ear problems, but I'm going closer to if you can just repeat the question.
Yes. In this transformation that you were explaining, you say you have a mother tube, and in that mother tube you perform 3 activities. But when analyzing it, you make this transformation so it's 3 times activity A that in reality just took place 1 time with 1 duration, and now you have 3
That's indeed a very good question.
And if it affects your analysis and how you handle it not affecting your analysis.
That's a very good question, because we struggle to take the right decision, and there is no right decision here. I think you can keep 2, let's say, process maps. One is really dealing only with the mother tubes. One is only dealing with the child tubes. One is only dealing with the result generated on the child tubes, which can be multiple as well. So, but at the time we had to decide, okay, what are we interested in? Is really seeing from one process end to end, and indeed with the bias potentially of this might take longer for the mother sample or for the child sample to go through all the activities. We knew that, but we are not counting in seconds here, not minutes, not hours, but days. So potentially, if it's 10 days, 12 days, we can manage that as soon as we have a view on where the process bottleneck is, where the inefficiency is. I think that is more the focus on process mining. Indeed, from a monitoring perspective, we'll need to think a bit further, okay, how can we manage that bias? But from a process mining perspective, we needed to know where the process bottleneck is, where we can go faster.
And if I may sum up just one thing, I think if you keep them together, having mother and child, and you look at the full picture of the process, then you are not looking at the same thing at a different stage of the process. So there you have some inconsistencies. So for me, either you keep only the mother or the child, or you split the process and you say, okay, for this part of the process, I keep only looking at the mother, and the other part I look at the child. Or as we say, we did here, we chose to replicate it into the mother journey into the child journey, so that we can see the full process, but without inconsistency of having modern children.
Thank you.
All right, thanks so much. I would say let's continue the discussion over dinner. I'm sure there's some more things to discuss. Thanks, Maxime and Maxime, for this presentation. Let's give you another round of applause.